Hello dear Robocup organizers and participants. In the following, Team Suturo from the Institute for Artificial Intelligence at the University of Bremen will show you how we managed to extract and execute our HSR. We will do so by presenting the software components responsible for the tasks of planning, reasoning, perceiving, manipulating and navigating, and additionally show further footage. We'll start with CRAM, the Cognitive Robot Abstract Machine. CRAM is a software toolbox for the design, the implementation, and the deployment of cognition-enabled autonomous robots performing everyday manipulation activities. This allows for lightweight reasoning mechanisms that can infer controlled decisions, which allows the plans to be more flexible and reliable. The symbolic expressions and the knowledge representation are grounded into the perception and actuation routines, and also into the essential data structures of the control program. CRAM thus makes the requirement to state the whole domain in an abstract knowledge base obsolete. NeuRoP is an open-source knowledge processing system designated for autonomous service robots. It represents the age's environment and belief state with axiomatizations using the web ontology language OWL. Recently, the Institute for Artificial Intelligence enhanced NeuRoP's functionality by developing SOMA, an ontological model that extends the agent's capability to perform everyday manipulation tasks. A key feature of this library consists of the fine-grained action representation. Since autonomous agents must often cope with shallow and symbolic instructions, they must be able to fill those informative gaps with detailed, grounded, and real-value information. In addition to that, NeuRoP provides a hybrid processing architecture where the components of the control program are reused in order to acquire experimental knowledge. Those resulting pieces of information can later on be used to find suitable action parameterizations in the real world. RoboSherlock is an open-source framework for cognitive perception. It allows the creation of different perception pipelines to appropriately handle a wide range of scenarios. Internally, it is based on the Unstructured Information Management (UIM). The different computational units are implemented as annotators, which can be seen as experts for a given perception task. The results of those experiments are then combined to find the best solution. Annotators are currently implemented with the usage of OpenCV and PCL libraries. GISCAT is a constraint-based motion control framework developed by the Institute for Artificial Intelligence and used for navigation and manipulation of the HSR. GISCAT allows to formulate motion control problems according to constraints which the controller enforces during the motion. These problems include motion constraints such as keeping liquid container horizontal or basic grasp positions. GISCAT plans full body motions that satisfy the bold description as best as possible. In the following footage, we will show how the HSR manages to perceive the surrounding and navigate through the environment. The agent observes the floor and any possible obstacles lying in the way. In case such an obstacle is detected, a collision is avoided by slowly navigating around it. Lastly, we demonstrate a simulation of our Suturo system using the HSR. In this case, we will show how the software components of the Institute for Artificial Intelligence interact with each other during the cleanup plan. The agent enters the arena and makes notice of the existing surfaces. By navigating to the first surface, RoboSherlock perceives the existing objects. The observed object type is then validated against NeuRoP's vast ontology entries. From the determined object type, NeuRoP then infers how the object can be grasped and where the designated placing area is. The motion control framework GISCAT can then slowly grasp the object from the surface and then navigate to the destination of the bucket. This is repeated with multiple objects on several surfaces. Thank you very much, and we are eager to compete with you.